Now we're going to talk about Standard 2, which was questions 11 through 16, identifying rates of change from a table. And so we're looking at the same tables we were for Standard 1. And here we had our first example was an exponential function that we found out because each of the values in the y or in the change of y is a multiple of 3. So 1 times 3 is 3, 3 times 3 is 9, 9 times 3 is 27. And it's the same whether you're looking at the change. 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54. And so if it is not linear, then it does not have a constant rate of change. So as soon as you know that it is not linear, you know that the change in y over the change of x, or rate of change, is not constant. And on the test, you abbreviated this as NC. You could say that it is, each value is times 3. So you could say it's the rate of change times 3 is how you go further. But how we've been talking about this is that the rate of change is not constant, and you can put that as an NC for this. It is not constant. Anytime you're multiplying, it is not constant. So taking a look at example 2, we saw that this was a linear function because the change in x was constant. They're all ones. And the change of y is constant. They're all increasing by 5. So again, if we're talking about rate of change, we are looking at the change in y over the change in x. You do want to look at both the x and y. Now, in this case, the change in x is 1. So when we take 5 over 1, you can just write it as 5. But we have other examples where the change in x and change in y are both constant, but the change in x is a different value, and it would not, it would change. You can't just look at the change in y, it would change its value. So in this case, the rate of change you could put is 5. Moving to example 3 and 4. So in example 3, you can see that we had a constant change of x right here, but we did not have a constant change in y. We had values that went down, and then we had values that went back up. And the second difference was not constant, so it was not quadratic. And there was no common multiplier for each of the changes or each of the y values, so it's not exponential. So this was none of the patterns that we're studying right now. Some of you might recognize this from the beginning of the semester as absolute value, but you don't need to know that. This is none of the linear, quadratic, or exponential that we're studying right now. So once you see that this is not constant, you can go through and look at the rate of change, being the change in y over the change of x. And you can look at each individual one of -1, but as soon as you know it's not linear, you know that the rate of change is not constant. And that's all you have to tell me. There's no number to give unless it's linear. So this is not constant. On your test, we were abbreviating that with NC for not constant. And then question number 4 from our previous example, change in x plus 3 for all of those, that is constant. The change in y was -4, decreasing by 4 each time. That is constant. So we know we need to find out what the rate of change is. And again, rate of change is change in y over the change in x. And so this is going to be change in y is -4 for everything. And the change in x is a +3. So your rate of change is going to be a number. And you can, if you're entering it in Schoology, you can write it -4/3 like that. It does not reduce any further. If it could, if this was, -8/2, you could reduce that to -4. but in this case, negative 4/3 does not reduce, and that is the rate of change for this. One thing I like to think about is looking at my rate of change. It's showing that it's negative. That means my Y values are decreasing as I go down my table, and that's just a good double check. I'm looking at my Y values decreasing. I see that my rate of change is negative. Those two things should correspond, so it's always good to double check that.